Hi, good morning, everyone. Good afternoon, everyone, beta. So today we are going ahead and we are taking question number question number 1B rather from 2021 paper. Okay. So what we will be doing is I will be checking this question and I will tell you what mistakes you have done and then you can go ahead and you can resolve those mistakes. Okay. Okay. So let us go ahead and let us read out this question once. If you have not tried it, I would ask you to go ahead and give it a try right away. Okay. So the question goes ahead and says that we want to go ahead and we want to understand what is generalized Lorentz dominance, and using that we want to show that lower inequality represents higher social welfare. Right? So let's see. The generalized Lorentz curve ranks income distribution by combining mean income and inequality. Okay. Where GLP equal to mu LP, where LP is the Lorentz curve and mu is the mean income. A distribution GL1 dominates GL2 if GL1 lies everywhere above GL2 and nowhere below. This is called as generalized linear dominance. Okay. So this is not true. यहाँ पे थोड़ा सा it need not lie everywhere above it, beta. यहाँ पे थोड़ा सा we need to edit the answer. What you will say, if it lies at least somewhere above and nowhere below. Mane, what's the difference? At least somewhere above and nowhere below, mane. For some portion, the two Lorentz curve can also coincide. And then one can be above and the other can be below. Samajh true? Are you understanding it? So it does not mean it has to lie everywhere above. It can happen that for some portion, there can also be a coincidence which can take place. They can coincide with each other. That is also a possibility. So you will say that yahan pe, you are going to go ahead and you're going to say that a distribution GL1 dominates GL2 if GL1 lies at least somewhere above GL2 and nowhere below. This makes sense. माने even if for some portion they are coinciding with each other, अगर वो एक दूसरे के साथ coincide भी करते हैं, then also it is fine. ठीक है, but it should not go below. ठीक है. Now since so another thing which is very important when you write answers, don't use words like let us see, now we see, now. We don't write that. Okay. So don't use these words. This is not good. Okay. You just say since welfare function is given as. You don't say now, then, we see, etc. Okay. W is equal to mu 1 minus G, where G is the Gini's coefficient. Correct. Okay. So G is equal to A upon A plus B, and 1 minus G will be B upon A plus B. Correct. Since 1 minus G is the ratio of area below under the Lorentz curve to the area under the line of perfect equality, okay. So here I want to highlight something. You notice that you have written this in words also. And that same thing, that 1 minus G is area under Lorentz curve upon area under the line of perfect equality. You have written this in formula also. So this is a duplication and not required. Even if you would have written it once, even if you would have explained it, it would have been fine. Okay, so this is not required. So 1 minus g is area under Lorentz curve upon area, because you've already written it here, na, that 1 minus g is b upon a plus b. And b is nothing but area under Lorentz curve. So you are continuing this formula only, right? So no need to write that line. Directly above this, you can write 1 minus g will be area under Lorentz curve upon area under the perfect line of equality. This is correct. So area under the Lorentz curve is area under perfect line of equality into 1 minus g. Correct. So this is going to be correct. Also, GLP is this in height of 45 degrees mu in a generalized Lorentz curve. Area under GL curve is this. Correct. Correct. This is correct. Absolutely correct. Okay. But once you have done this, once you have explained this, right? So you need to also go ahead and you need to also tell what your W1 and W2 are. Okay, because you are taking two Lorentz curve. So you can go ahead and you can just say that in this sense, your W1 can be mu1, 1 minus G1, and W2 can be mu2, 1 minus G2. You need to define what these W1 and W2 are. ये जो आपने दो लिए हैं, what these means, you will go ahead and you will define this here, right? So then you can say that if W1 is greater than W2, it means area below generalized Lorentz curve of W1 is more than area below generalized Lorentz curve of the other curve. Okay? So this is correct. Okay. Now, because you're using Sherlock's theorem, right? So, whenever you use a theorem, okay, this, you must go ahead and you must first define the theorem and then you should invoke the theorem. So, what I'm saying here, for this last paragraph, you will first define the theorem and then you will invoke the theorem. You should not use the theorem unless you define it, because we don't know. I mean, when you are going in a paper, when you're writing a paper, you don't know how well your theorem will be interpreted in the question. तो उसको हम कभी भी directly नहीं use कर सकते. We have to go ahead and we have to make sure that we first define. So what is Sherlock's theorem? That as long as you have same preferences and your utility functions are strictly concave, right? Then generalized Lorentz curve dominates another generalized Lorentz curve. It represents that the first generalized Lorentz curve will have more welfare, right? If some Lorentz curve dominates the other one, right? If GL1 dominates GL2, then GL1 represents higher social welfare. So first of all, you have to go ahead and you have to tell what that Sherlock's theorem is. And once you have told the Sherlock's theorem, so you can say that here, because we have assumed, in one line I explained what Sherlock's theorem is. Now I will invoke it in this question. So I will go ahead and say that now, using that Sherlock's result, we can say that since GL1 has a dominance over GL2, therefore that first one is representing higher welfare using that theorem, right? So when you tell what the theorem is, when you tell that what the assumptions behind the theorem is, only then you can tell that I am using it here, assuming that those assumptions are satisfied, assuming that for those two Lorentz curve, the preferences are the same and we have strict concavity of the individual utility function. So assuming that, you go ahead and you give your answer. Is it making sense? So more or less, this is a good answer. And I will give you 4 out of 5 here. But I just want you to make some changes here and there. First of all, when you write this, it should be somewhere, at least somewhere, not everywhere. We don't require that one Lorentz curve has to be above other Lorentz curve. The two can coincide for some part and then one can be above another. So this is also fine. This is also a dominance, right? So that's the first thing which I want you to correct. The second thing is you defined this W, but because we have defined two Lorentz curve, whenever we use W1 and W2, we define them in formula what those are. Third thing is there is no need to write formula in words again and again. So if I have written a formula, I don't mention that in words. I just directly imply what it means. And the last thing is that whenever you use any theorem, okay, whatever theorem you go ahead and use in economics, you make sure that in one line you explain that theorem and only then you invoke that theorem. Okay? So good attempt to the question. Is it clear? Any question you have here? Okay.